The cloud story is around, let's say, for almost half a decade now. And it's again the industry which says, you need to go to the cloud, and the cloud is a big new thing. And well, we've heard that stuff quite often in the past. And we are all a little skeptical. We say, okay, blah, blah, this is the big story. Who really needs the cloud? And we would say, okay, now we want to sit down with some experts and speak about what the cloud can mean already today to developers, to ops, to businesses. And the important thing is, we just said, okay, we want to nail down not the, we don't want to speak about the basics, yeah? We don't want to speak about the cloud propaganda. We really want to sit down and find out, okay, where can we identify some cases where the cloud really matters? And of course, it's about many, many different cloud technologies. In the end, is the question, is there one cloud, or do we more speak about, let's say, cloud concepts in plural? And so that's it's all about. And of course, I prepared a few questions, and which we are going to discuss right here on stage. But if you also want to contribute to the conversation, and if you also want to ask a question, please raise your hand. Yeah, and I think there's a microphone. Yes, yes. And then please join the conversation. Just raise your hand and tell us that you'd like also to say something, or that you would like to ask a question. Okay, so now I'd like to call up on stage Glen Campell from Rackspace. Please welcome him. Secondly, Frank Müller from Canonical. He's working on some Ubuntu systems. He is just explaining it a little bit more exact to us in a few minutes. And last but not least, Rainer Stropek. He is working on with Microsoft technologies and can tell us a little bit. And he's really doing 100% or 99% cloud-based business. That's really interesting. So please welcome Rainer. So now this was a little intro from my side, but I feel it's much better that you guys going to introduce yourselves a little bit. And please explain the audience also a little, what's your approach towards the cloud? Maybe Glenn, you're starting?
Sure. I work for Rackspace. Rackspace, if you're not aware, is the second largest cloud provider on the earth after Amazon. We're an infrastructure provider, so we offer cloud servers, cloud storage, cloud databases, and all the things from which you can build your application. And we're working very closely with the OpenStack Foundation, which has an open source cloud management software that if you want to run your own cloud, you can go download it and run it yourself. We're sort of working up the stack. We used to be a dedicated hosting provider, and see the cloud really as the future, though we still have the dedicated hosting as well.
Thanks. Frank.
Yes, many of you already know Canonical from Ubuntu, used as desktop operating system or as server operating system. But we are also developing other open source products, and one of them is Juju. That's a product the team where I'm working in is developing. And this is a software, this is the idea of, yes, provide a more simple provisioning of server infrastructures independent of the underlying infrastructure provider. So if you use Rackspace, Amazon, if you use any other OpenStack provider, the software Juju helps to provide services in pre-configured, yeah, we call them charms, on these systems.
Thanks. Rainer.
Thank you, Sebastian. Yeah, my name is Rainer Stropek. Compared to my other two colleagues, my company is really small. I run my own business. It's a small company. We're just a bunch of guys running software as a service in the cloud. We founded our company a few years ago with the express purpose of using and living and breathing and building software in the cloud, software as a service. We have one flagship product, which is called Time Cockpit. And we also build and help other companies and teams to get their software in the cloud. And I am a 100% platform as a service guy. So I spent enough time of my life in dark cellars installing servers, and I don't want to do that anymore. I don't want to care about the infrastructure. I just want to platform and deploy my applications there.
Great, thank you very much. So maybe we ask the audience just to understand, or just so that you can also introduce yourself to us. Yeah. So maybe please raise your hand. Who has already, let's say, experimented with some cloud technology, whatever it is? Okay. Who has already built or builds a system which is running in the cloud? So really, okay. And who here has already built many systems running in the cloud, like Rainer, for example? Okay, Rainer is the only pure cloud guy here in the room. Yeah. Very good. Okay.
We're with you.
So let's start about speaking about well, the cloud, because in your session you said, okay, all the presentations about the cloud start with a photo of the cloud, and we see something very fuzzy. Maybe we can sort the field a little bit. So, for example, you guys at Rackspace, and you are the key sponsor, right, of the open source framework OpenStack. Mm-hmm. This is more infrastructure as a service. Maybe you can explain a little bit more. What exactly does this mean?
So the OpenStack Foundation started as a joint venture between NASA, the Space Administration in the US, and Rackspace. Rackspace contributed what became known as Cloud Files or OpenStack Swift, which is an object storage in the cloud. And NASA contributed something called Nova, which was their internal compute management. So starting from those two, the OpenStack Foundation then added various other types of infrastructure as a service, load balancers, databases, and they're moving up the stack. They recently announced a project called Solum, which essentially is a platform level abstraction as well. But I think the key there is that these are all infrastructure components that are provided via a web service. There's an API that you can call and create a server using virtualization. So you specify how big a server you want, what operating system flavor you need, and it goes off and constructs that for you and handles the management of it. The technology, I think, is all pretty standard. It's just the fact that unifying the management of that across a huge number of actual physical servers is where the difficulty is, and that's one of the things that the OpenStack code tries to take out of the equation by making that open source.
So the cloud is always about the idea of a service, and the service is all about the idea of I don't want to look behind. So, for example, if you go to a restaurant, there are new fashionable restaurants, you see the kitchen, yeah, which is kind of contradictory, because normally I don't want to see the kitchen, I just want to have a good service, yeah, but on the other hand, people like to look into the kitchen because of it's looking nicely and it's clean, etc., etc. But coming back, it's all about I don't want to care about what's behind, and especially even more than that, our customers don't care about infrastructure or implementations.
I don't want to have to unbox it, cable it, add in power, pay for all that, pay someone to management. I just want a server to use.
Okay.
But Sebastian, it is one thing that I don't want to care about installing all this thing, but I do definitely care about what's going on behind the scenes. So when I select a cloud platform and when I help customers selecting a cloud platform, we do look behind the scenes. What are the service level agreements? How professional do they act? I visited one of Microsoft's cloud data centers and took a tour around it, and I have seen the infrastructure. And this is important for me. So not caring about the infrastructure does not mean I don't care how they handle my data. It just means I don't want to bother with installing all this stuff and keeping it alive like a small Tamagotchi living in the cloud that you have to feed and breed and all this stuff. I don't want to care about that.
Great. The idea of the cloud is also associated to, let's say, the idea of infinite resources. Is this true? Doesn't this make sense?
No.
No.
It can look like that.
Yes.
The goal is to make an interface that looks like there's infinite resources. And in fact, there never is. There's always a finite amount beyond there. And so for most people, it is virtually infinitely expandable. In other words, they'll actually run out of room on their credit card before they'll run out of compute storage that they can get, or they'll hit some other limit. But there's always a finite limit there. There's a fixed number of physical servers you can put in a data center, and you're going to hit that at some point.
That's definitely true. I think that's an important point that people who are really serious about the cloud have to think of. They need some kind of contracts with cloud vendors that guarantees them resources to a certain degree. It's like in this hotel. If you step in at 10 o'clock in the evening and you say, I need a hotel room, it may happen to you that they don't have one. So you need to have a reservation. And it's the same for all the cloud providers. So to a certain degree, you're just exchanging hardware sitting on stock in your back room with contracts. It is a little bit of fixed costs, but to a certain degree, you will also need it even if you go to the cloud and you have this variable price model. So if you're serious, you need some contracts.
But it's indeed more flexible than having an old-fashioned, yes. Given or taking your model, you don't have to rent own building in the city you want to take a night. You go into a hotel. So the cloud providers do provide a contingent of infrastructure to you, and yes, you have to rent it for a night or for some more night.
As this is mainly a development conference and not an operations conference, I'd like to understand a little bit more what impact do cloud technologies have on software development or software engineering today and or in the past? What do you guys think? So in the end, it's all about, well, if I'm developing a system today and I don't care about where it's running, I won't care tomorrow if it's a cloud, yes or not. The question is now, do we do the same or do certain parameters change our work and how we build systems?
It definitely changed. Where in the past the typical system administrator has to care for the limits of a physical machine or of a number of physical machines, the understanding is now moving into how clouds are working, how cloud infrastructures are working, how, for example, choosing the right region of Amazon infrastructures or regions are working. So this has influences on the latency of the data flow. And so the administrator, yes, will not be the administrator as it has been in the past. We are talking about DevOps here. He's moving closer to the developers, but he still has to have knowledge about the infrastructure where the services are running on.
But in terms of software development, so for example, we've spoken about testability.
Yeah, I think one of the interesting things that a few months ago, we started offering free accounts for open source projects. One of the unexpected side effects of that was that a lot of these open source projects are now available on Windows, for the simple fact that before, being a nonprofit with no income and an open source project, they couldn't afford to buy a Windows license. But now that we're giving the ability to spin up cloud servers on demand running Windows, they can now offer their software on Windows and not be Linux specific. If you're a developer, it gives you the ability to call up different environments on demand so that you don't actually have to go out and physically purchase those machines to run it on. And moreover, you don't have to keep those machines around if you're not using them. So
yeah, exactly.
If you have a 6-month release cycle and you do integration testing the last month of it, well, then you spin up your servers for testing then. You don't have to pay for them the other 5 months of the time.
From a developer's perspective, I think this is a very important point because the main gotcha that many developers have when they go to the cloud is that they have to remember that in the cloud, the servers can change from 1 minute to the other. If you are in your own company, you have this server and you build it up and it will stay the same server for months, even not maybe years. But in the cloud, you deploy your software to a server, you scale it out to 3 servers, and maybe the cloud provider decided to put this one down and put the data or software or your application to another server, and your software has to handle that. I always tell developers that when they go into the cloud, they have to develop software that is ready for scale out and not scale up. Buying a bigger web server, if your site gets more traffic, is not an option. Adding more servers is the correct thing. And I think we have to keep that in mind as software developers, and that changes some things. That changes how we deal with state, with data, and things like that.
Yep. The influence on the architecture of your solution is immense. It's a distributed application, and that's an absolute difference from the typical, one request-oriented, I'm handling this request application, like many web applications today are. It's not synchronous anymore. I have to use other technologies like message queuing, and the cloud provides the infrastructure to run this, all the services, depending on what you use.
Scaling out the notion which developers and architects needs to care most?
Well, yes, and the other thing is latency. I'm not building the next Facebook or the next eBay, so I build small to medium software. And many teams that I know that have, for instance, performance problems with the database and a web server, what do? They buy a bigger server, they put the database and the web server on the same machine, so they don't have a network cable in between it, and boom, the software is faster. That worked for a lot of situations for small and medium software developers. But in the cloud, especially with platform as a service, you can't install the database server on the web server because you can't access it. So you have to keep that in mind. I always try the analogy of IKEA. When IKEA builds a new table, they are not starting with building the table. They are starting with calculating the economy behind it. They are thinking how much money is it okay that this table costs, and how will people put it together and things like that. And then they adapt the materials, the production process to what they want to build. And if you go for platform as a service, you don't think of an architecture and then try to map it to the platform services. You take a look at the platform services, do the math, think about how can I smartly use this service with this service, and then adapt your architecture to the platform that you want to target. And then things are paying off because you are really using the power of the platforms.
And given the fact that, as you said, that setting up servers or infrastructures is much less complicated on a PaaS or even on an infrastructure as a service level, couldn't it be that, let's say, architecture becomes much more, let's say, experimental?
Sure, that's one of the cool things that I love, is that architecture traditionally has been the fixed part of the equation. You decide what servers you had, and you go purchase them, and maybe purchase them more a few years, but you're stuck with what you have for that moment. When you have flexible, elastic infrastructure, you can say, let's try a different architecture. You can prototype things that involve an utterly different arrangement. There was a presentation yesterday on reversing your architecture, and some discussion as to whether or not that would work in various scenarios. Well, with cloud, you spin it up, you test it, you see if it works, it costs a few dollars. It's not like you have to make a major capital investment to it. Suddenly you're now prototyping architectures and not just code.
Exactly. The way of simply create new configurations of different services, of different resources in your infrastructure, scale it out really big for test purposes, and then, in the same moment, if you say, I don't need it anymore, destroy the whole environment, is yes, a matter of some minutes, so, okay, a bit more. But it's a very small amount of effort, and you don't have to buy huge racks and huge infrastructures and keep them the whole year for your tests. No, you just can test it.
Mm-hmm. I can really support that because recently one of our clients asked us whether our piece of software that we have written is ready for 30 million transactions, business transactions per month. So I could have sit down and calculate and think about it and promise it, but I did the opposite. I told him, you know what, let's try it. Let's spin up 20 machines in the cloud, generate some test data, buy a load generator also running in the cloud, fire these transactions to the system, and simply measure it. That's simply not possible in the cloud. In this talk, it's called What's in for me and my business. I would turn it around. It's a no-brainer. I cannot imagine doing business anymore without the cloud because I couldn't do such things. Our competitors who are not using the cloud cannot offer this service to customers. And I think it's really important to have this ability to try and test and play.
It's even fun.
Absolutely.
It's fun.
Yeah.
Any question from the audience? Maybe. No? Right. Speaking about operations, we've been now saying, okay, it's much easier. No, there's no need to install something. It's much easier to set up something. I hear very often that admins say, oh, does my employer need me in the future if he's going to the cloud? Probably yes, but can you speak a little bit about how the profile and the skill set of, let's say, operation guys should change? What should they care about today and in the future, heating the cloud?
I think it's one of those things that matures over time. The skills are still there, but they're going to be used in a different way. If you were a COBOL programmer 20 years ago, you can make a lot of money, but you couldn't expect to stay a COBOL programmer forever. You have to adapt and change. Likewise, operations people are doing operations now. They can't expect to sit there and manipulate physical hardware. They need to learn more about deployment tools. They need to move more into the programmable infrastructure end of things. And thus, they're going to become more and more developer-like. We use the term DevOps very commonly. So there's now a blurred line between that. And so the same people are there. They're just doing different things.
Scaling out brings different kinds of problems with it. Distributed applications bring different kinds of problems with it. So the knowledge of the operators, of the DevOps, have to change into this direction and has also to support the developers in those areas, because many developers still don't really care for topics like net splits and large distributed applications and synchronization of states. And here, that's what you said in the preparation. Handling state in a distributed application is something totally different than in old one-box applications.
I have 3 points in this area. If you are an IT admin and you want to stay an IT admin, concentrate on networking, because networking is super, super important, because your company has to be connected to the cloud, and managing this in a reliable way, it's a really complicated topic. We will need IT admins for networking for a long time. Second thing, if you're an IT admin not working in the networking space, you should probably forget about walking with a DVD to a server, installing an operating system, but concentrate on learning things like PowerShell and things like that to spin up machines in the cloud, public or private, doesn't matter. And the third one, if you are a developer, learn about operations. Because in our company, every developer is an operational person. Every developer who builds kind of service, running in our case on Windows Azure, has to know how to deploy this stuff. And the developer writes the PowerShell scripts and deployment code and build automation to deploy the stuff. This is DevOps. So DevOps is not only moving operation people to the dev world, but also making developers understand how IT operations work.
Yep.
This is maybe not entirely something new to the typical web developers. Yeah. So maybe let's ask the audience: how many of you, beyond the cloud now, are developing and also, let's say, installing and administrating web servers, etc.? Please raise your hand. So this is already a DevOps community, right? So, so what should they look on heading towards the cloud technology in specific? Should they all use Puppet and Chef and all these tools, or what's in particular?
Those are certainly the most popular ones. The newer ones are Ansible and SaltStack that are coming up. The key is automation. We're moving away, the whole industry is moving away from having expensive people working on one server at a time doing manual tasks. The goal is to automate everything so that you can streamline that.
Yep, exactly. Automation in clouds is a new. Yes, it's the same as automation on a single server, but the technology is moving to Chef, Puppet, Juju. There are new technologies rising based on the experience the first adopters of cloud technologies are now making, and this grows more and more. And so over time, the knowledge has to move into this area too.
I'm a Microsoft guy in this panel. So in the Microsoft world, we see even the next wave coming. You see application lifetime management, ALM tools running in the cloud. So recently I've been at a customer site where they have a development team with 20 to 30 developers, let's put it this way, approximately, and they want to build an entire ALM stack with automated build, work item management, Scrum, and so on for more than 6 months now, and they couldn't make it work just because infrastructure didn't have the time to provide the necessary servers. I went there, I showed them Team Foundation services. Within 20 minutes, we had everything up and running. We had source control, we had work item management, we had build servers, and we fully integrated continuous integration and deployment with platform as a service services in the cloud. So we just checked in our new website. It was built in the cloud. The tests were running in the cloud. It was deployed to Windows Azure. We could scale it up. And we have never, ever even thought about a server IIS or things like that. So I think an integrated system with ALM at the beginning, continuous integration and deployment, and platform as a service in the cloud is really something that small and medium teams should look at, because it reduces their cost and it makes them super productive. Having this little advantage in comparison to maybe large competitors who are struggling with infrastructures.
There's a bit of a warning there too, in that if some parts of your company are getting involved in this, it can be very embarrassing if you're not. When we were talking about deploying our cloud, our next generation cloud at Rackspace, that team made the decision actually to deploy that cloud on a private cloud internally. So sort of like Inception, but you're running a cloud on a cloud, but nevertheless you have those benefits. And in one of the planning meetings, they said, how long will this take to deploy? Well, the team that's running the back-end systems that does the billing and the customer account management said, well, we need to order the servers. It'll take 3 or 4 months, and then another month or 2 to configure them and get them up and running. So let's say 5 months. And the front-end team that's running the cloud software said, well, 30 or 40 minutes. It can be really embarrassing if you're not able to keep up with that. So we could have this job done tomorrow, except for this team that has to manage the hardware, and therefore it's going to take 5 months. So that's where you need to look at some of the benefits there for your business, is moving quickly and not having to get behind the curve on ordering and maintaining hardware.
And one of the problems too might be that the technological possibility is there, but the company policy stands against it and says, it's nice that you can do it, but we don't want it. Our data in the outer clouds? No, in public clouds. So here's many work to do to convince the management to handle it, or to create private infrastructures that provide cloud services to the internal company without leaving the company. But it's still networked.
I think the CTOs have to keep exactly that in mind, because a modern infrastructure that wants to balance private cloud and public cloud has to make some decisions so that the developers can write code and package it in a way that it can seamlessly flow between public and private cloud. So I want to have an infrastructure in my data center where I can take exactly the same bits and run it in my private data center, and take these bits and run it in the public cloud. It's not an option to make everything by hand inside and do a completely different packaging and deployment algorithm in the cloud. I think this harmony is really important for enterprise ITs to try to come up with this private cloud, and not only a data center with a bunch of servers managed manually.
So if we say, okay, the cloud is all about service, and developers are able to really concentrate on what matters. That means building services, and not being distracted by other tasks. And on the other hand, given the fact that no technology is the silver bullet for everything, so maybe you can tell us a little bit where are there some cases where you would not recommend to use some cloud technologies? Is there some examples from your perspective?
I think there's certainly a reason to avoid public cloud technologies, because there you're sharing resources with other potentially evil people who want to do bad things to you. So, if you're a financial services company, you do lots of highly valuable transactions, you probably want that isolated. That could be an isolated server, that could be an isolated private cloud, though, in which case you're running cloud software on your own data center, in which case you get the benefits of cloud, but you don't have the risk of sharing that infrastructure with other people. So it's not a perfect solution for everything. There may in fact be situations where you get more compute power by having a dedicated machine for it or something. I can imagine that. Yeah. So it's not a silver bullet. It's not going to solve everything. But you can even apply cloud technologies to physical hardware. OpenStack, for example, is working on an API for spinning up physical servers. So the idea is that you have a rack of servers pre-planned. You now have a management software that says, I need a server. It'll go out and provision it, and 5 minutes later, you have an actual physical server that you could use just as if it were a cloud server.
I also think that there are situations where the cloud is not appropriate. Security, of course, I don't want to go into any details here because everyone is aware of that. But the cloud is really all about giving away responsibility, but also about giving away control, about gaining economy of scope, economy of scale effects. And if you have just one application, and it's really complex, it grew over the last 10 years, and you have mixed up Delphi and C++ and .NET and PHP, and it's super complex to set up this machine, and you just have one server, automating a deployment process for such an environment would cost a lot of money and time. So it doesn't pay off. Just rent a server at Rackspace or whatever, remote desktop in it, and set it up and run it. It's not cost efficient. I think it's cost efficiency from the cloud comes with economy of scale and economy of scope. You have to do a lot of similar projects, and then you can have benefits.
Yep. Also, you have to think about the planability of outages in case of that you are providing or running a service that is that needs really to run 24 hours each day, and with your own IT, you can plan your own outage for maintenance reasons. But if your provider is an external one, like Amazon, they are planning it. So that's a control you're giving out of your hand, and you have to take care that your solution can handle this, e.g. by putting parts on different providers and different environments so that you can have a kind of HA solution independent of the cloud provider.
SLA is important, and that's one of the driving things there. It might be nice that Amazon or Rackspace will give you a payment for being down, but if you're running a police or a fire department, you can't afford downtime. You want that to be up always. And so simply saying, oh, I'm going to get a payment because it was down for 2 hours on Sunday night is not valuable to you. You actually need to have the service continually running, and therefore that's when a situation you may want to run your own hardware and pay that expense for it.
But the question is, are you able to run your own hardware and software better than the professionals out there do?
That's always the question. Is there a payoff there, and what is it? At least it's somewhat under your control. If you're a city government and there's a massive storm and it puts everything out, well, then you may be in a situation where your system is down, but the cloud stuff is still running. The question is, has cloud got the reliability to compete with a dedicated operations staff there? And that's really the decision that you have to make.
I think this area we have to be aware of, that we have one limit that we cannot discuss away, and it's simply the speed of light. So if I run my application in, I don't know, Dublin, and the only users using this stuff is a local government sitting here in Germany, then you have a latency problem, and it is definitely ruled by the speed of light between Germany and Dublin. So if you run your server locally, then it's there, and if there is a big thunderstorm that blows away the whole internet in Europe, you still have your server in your room, just beside you, and you can still use it.
The converse of that, though, is, of course, if you're a small business in Germany and you want to expand out, you can go into a cloud provider that has data centers in Hong Kong, in Sydney, in South America, and not have to incur that expense yourself to set those up and run them.
Sebastian, can I add one more thing? Because I'm always wondering, in such an audience, why so little people, only a few people really use the cloud for production? And I have the experience that in a lot of cases, management, whoever management is in these companies, just says, hey, no cloud, it's too risky for us. I really want to encourage developers to just ask and educate. I think it's important for us as developers to try it and tell our management that business offerings are not Facebook or eBay or things like that. There is a big difference between consumer cloud, like Facebook, and business cloud for running business applications. And I think that we as developers have to educate management so that they understand that it's not careless use of data, putting it somewhere in the cloud, and then immediately we also get management support because there is a business value in the cloud.
Yeah, 100% agree. We, as early adopters, as developers, have to get aware of those possibilities, of those technologies, of the pros and cons, and then take this to convince the management that clouds are just a tool, and a very good tool, and this tool can be used in many business cases and is helpful in very lots of business cases. But it's us to develop, to educate the management.
Maybe this conversation made a few people a little curious on the different concepts. So as a last question, maybe I'd like to ask all of you, or please give the people right here in the room a hint. Where should they start? So how to try out? What would you recommend?
Well,
it's the very first step to get a little bit more experience and maybe something to document and some experience which you can document and forward to your boss, etc.
Well, if you go to developer.rackspace.com, there's a link there. You can sign up and get a free credit for 6 months. So you can go play with it. A lot of people get started there. Amazon has a similar program, as well as do others. I'm sure Azure has something like that that's low budget. And the cool thing is, you don't have to shell out thousands of euros for a server. You can get it free and spin up servers and try this and then demonstrate it to your management very easily and at almost no cost to you.
Exactly. It's simply try it. Most providers want to have you as your customers, so they provide a program for open source developers to adopt those technologies for no price, or they provide you a small number of resources, but it is enough for testing so that you can test it, make your first experiences with it. And there are different ways that, yes, infrastructure as a service, as Rackspace is providing, Amazon is providing, or platform as a service where you use the API of the provider, as Google App Engine or Microsoft is providing.
I would like to make my statement as concrete as possible. If Microsoft is a possible technology for you, not .NET, could also be Node or whatever, but if Microsoft Cloud is an option and you have an idea, being an entrepreneur like I am, for instance, check out the Spark programs of Microsoft. Things like BIS, Spark, Dream, Spark. You will get for more than 2 years a lot of money, free cloud resources, free Visual Studio licenses, free licenses for servers to run, I don't know, some Active Directory in your company. It's absolutely free, and it's there for people having an idea and want to try it, simply try it. Failing is okay, you can try multiple things, but you don't have to invest a lot of money. So DreamSpark, BizSpark was of great help for us living in the Microsoft environment, of course, because it's a Microsoft program.
So thank you very much. I think we've seen that maybe cloud technologies is not for every particular business today relevant, but we can all be sure cloud technologies in the future are going to matter in every case. So thank you very much. Thanks for the panelists here, and enjoy lunch. And it was great to have this conference together with you. Enjoy the afternoon. And yeah, it's time to say goodbye.